Hi, welcome to Notes 4.6. And in these notes, we are going to go beyond proving triangles congruent. We spent the last set of notes talking about all the different ways that I could prove triangles congruent, and it was pretty straightforward. Now we're going to go beyond that. What happens once I've proven triangles congruent? And once I've proven triangles congruent, then all of the corresponding parts of the triangle are congruent, and therefore I can use these parts to either say the parts themselves are congruent, or I can start talking about if these parts are congruent, then the lines are parallel, or they're angle bisectors, or they're segment bisectors. There's all kinds of options once I've proven triangles congruent. I can even use the parts to prove a different pair of triangles congruent. And once we've proven triangles congruent, we can make this statement that corresponding parts of congruent triangles are congruent. And we abbreviate this in proofs to CPCTC. It is super handy. We are going to use it a lot. Be sure that you know what CPCTC stands for, because we're going to ask you several times on several different assessments throughout this unit what CPCTC stands for. And also be sure that you know that you can only use it once you've proven two triangles congruent. Okay, so here's how CPCTC works. If I need to say that segment BC is congruent to segment AD, then I need to prove these two triangles congruent first, and then I can say that these two are congruent by CPCTC. So can I prove these two triangles congruent? Well, this side is congruent. These two angles are right angles, and all right angles are congruent, and they share this side. Therefore, I do have enough information to prove these two triangles congruent, so I have triangle ABC is congruent to triangle CDA, and the reason for that is side angle side congruence. Once I've made this statement, then if I were doing a proof, I could go ahead and I could make this statement, and I could say that segment BC was congruent to segment AD, and the reason for that would be CPCTC. Beginning to see how it works? All right, so what I want you to do is I want you to tell me why the triangles in 2 and 3 are congruent. Write me congruent statements and give me the reason. That would then allow me to say that these angles are congruent to each other. So do that now, hit pause, come back when you've got answers. Okay, you should have gotten that these two triangles are congruent by angle side congruence, which would then allow you to say that these two angles are congruent by CPCTC. And you should have also gotten that these two triangles were congruent by side congruence, which would then allow you to say that those two angles were congruent by CPCTC. Okay, so let's do a whole proof now. So I need to prove PR is congruent to QS. PR is this whole diagonal right here, and QS is this whole diagonal right here. And I'm given a little bit of information. So let's begin our proof by using that information. So if it's labeled in my diagram, it's given to me. I know that, let me see, angle SPR is congruent to angle RQS. And I can't just use the letter of it because there's multiple angle P's and multiple angle Q's. So that is given. And then I know the other piece of information I'm given is I know that segment ST is congruent to segment RT. And that is my given. Now, I do have one additional piece of information. This triangle right here, of which QS is part, and this triangle right here, of which PR is part, they overlap and they share this side right here. So I do know that SR is congruent to itself, although I'm going to call it RS. And my reason for that is my reflexive property. So my reflexive property of segment congruence. All right, so where do I go from here? Well, this one was strange, right? This little segment, because it's part of this triangle right here. And I could prove that this triangle is congruent to this triangle right? I don't know if you can tell what I'm talking about, so let me highlight them. I love highlighters and proofs. I could prove that this triangle is congruent to this triangle if I used vertical angles, but that doesn't help me a whole lot unless I want to do a ton more, because PR is the whole side, and that would only give me PT. And I guess I could add them together and it would get all complicated. But there's an easier way to do that. So let me erase all of this. And let's talk about the easy way to do this proof. Well, excuse me. If I'm given this, then what I actually have going on here is I have an isosceles triangle going on, right? And we know from our past unit that if two sides of a triangle are congruent, then the angles opposite them are congruent. So I can go ahead and I can make the statement that angle PRS is congruent to angle QSR. And my reason for that is, in a triangle, if two sides congruent, then angles opposite are congruent. All right, so now what I have going on here, and it may be easier to see if we actually redraw these triangles. So I'm going to split these guys apart. And I have triangle P, S, R, and I have triangle S, R, Q. And we've already said that this is true, and we've said that this is true. And now our last statement told us that this was true. So what we actually have going on here is angle, angle, side. So I can go ahead now and I can say that triangle PRS is congruent to triangle QSR, and my reason for that is angle, angle, side congruence. And now that I've proven two triangles congruent, now I get to use my old buddy CPCTC. So PR is congruent to QS. That's my statement. That's the thing I needed to prove. And my reason for that is CPCTC. Now there were other ways we could have done this proof, but this one is going to be the shortest and the most direct. But you know, if you saw a different way and you felt really strongly that it should go another way, that is perfectly okay. And so we've got some givens and we've got a diagram, and let's see what's going on. We've been given that yx is congruent to wx, and that is marked in our diagram. And then we're given that zx bisects angle yxq. Well, yxw. So yxw is this angle right here. Zx bisects it. To bisect means to cut into two congruent pieces. So there's my two congruent pieces I'm going to label. And then the final thing I'm told is I need to prove that yz is congruent to wz. All right, so this is what I need to prove. I need to prove this is congruent to this. So we've got some steps written here, but I'm going to talk about this as if we don't know what the next step is. So the very first thing you need to figure out is you need to figure out what triangles can you prove congruent, and does that help you with those segments? Okay, well, I can prove this little triangle here congruent to this little triangle here, right, because they share this side, side angle, side. But that does not help me with these because those are not part of that triangle. And those are part of these triangles right here, but I don't know anything about them other than this. So that is not helpful. So what I do know enough about is this big half triangle right here and this half triangle right here. I can prove that these two are congruent to each other because we've got a side, an angle and an angle, and they share this side. So we have side, angle, side going on. So these are the two triangles that I'm going to prove congruent of the three possible triangles that I could prove congruent in this. So let's go ahead and do that. All right, we are given that those segments are congruent. We are given that that is an angle bisector. Now, up here I said because it was an angle bisector, then I could go ahead and say that those two angles were congruent, which means that what goes in blank 3? I'll give you a moment to think about that and to write it down. Did you say definition of an angle bisector? Then you were right. All right, so that's my definition of an angle bisector. And then XZ is congruent to XZ. What is the reason for that? I'll give you a moment to write it down. Okay, so that is my reflexive property of segment congruence. All right, and now I can say that these two triangles are congruent to each other, and we said that was due to side angle side congruence, which means that, what is the reason I get to say YZ is congruent to WZ? I'm pausing so you can write it down. CPCTC. What does that stand for? Did you say out loud in your bedroom, corresponding parts of congruent triangles are congruent? Good. All right, moving on. Okay, you're given some information about each of these pairs of triangles, and then you need to prove some information about each of these pairs of triangles. I would like you guys to attempt these proofs on your own, and then come back and check your answers once you've completed them. So hit pause now. Okay, for this triangle over here on the left, you should have recognized that my vertical angles were congruent, so you could have used angle, angle, side. So what needed to happen was you needed to make these three statements prior to stating that these two triangles were congruent by angle, angle, side. I don't care what order these statements are in, they just all have to happen before you make this statement. And then once you've made that statement, then you can go ahead and you can say that those two segments are congruent by CPCTC. All right, be sure your triangle is written so that all of the corresponding angles are in the right place. Okay, on this guy over here, I went ahead and put the segments that were congruent and parallel. I put them in the same step. You could have split them out into different steps. That's okay. And then you should have recognized that if we were given parallel lines, that meant that my alternate interior angles were congruent. And it must be this pair of angles. Okay, it cannot be this other pair. Okay, because those are not the lines that are parallel. So that doesn't prove those angles congruent. It's got to be these two angles right here. And then this segment that they share is congruent to itself by reflexive. So again, all of these could be in a different order. You had to say that these lines are parallel before you said that these angles were congruent, but you could have put the reflexive first if you wanted to. And then you would have said that these two triangles were congruent by side angle side, which meant that my two segments were congruent by CPCTC. How'd you do on those? If you have questions on those, be sure you ask in class. We're going to be talking about overlapping triangles. And the key thing to remember about overlapping triangles is that they are triangles that share either a side or an angle. And those parts, the side or the angle, are usually going to be used when we're proving two triangles congruent. And that means that the reflexive property is typically going to show up in these proofs. And so let's look at some overlapping triangles and see if we can figure out what the parts are that make them overlapping. So in this first pair, they don't overlap by very much, but where they do overlap is right here in GH. GH is congruent to itself, which means that we've got an angle, and then when I add these two guys together, since these two parts are congruent, when I add the same thing to both sides, I wind up with two congruent sides. So I have, let me see, triangle KNH is congruent to triangle MTG, and that would be angle, angle, side congruence. Okay, this pair of triangles overlap a lot more. In fact, when they overlap, they form a bunch of different triangles. So sometimes students get confused as to what triangles they're trying to prove congruent. And sometimes it helps to redraw the triangles and sometimes it doesn't. So the very first thing is we have to figure out what triangles we're talking about, what pieces overlap. Well, angle B kind of looks maybe like it might overlap here, although there's sections of angle B that are left off. So perhaps we're really talking about ED here, that both of them share and overlap. And oftentimes highlighting helps, at least it helps me. So if I look and I highlight this big triangle right here, and then with a different color, I highlight this triangle right here, I can see which two triangles I'm talking about. So essentially, I've got triangle ABD, ABD, and I've got my green triangle is triangle EBC. And we already know that A is congruent to C, and we know that D is congruent to E. And since these segments are shared, or this segment is shared and these two are congruent, when we add, we'll have this side is congruent to this side. So basically what we have going on here is triangle ABD is congruent to triangle CBE, and the reason for that is angle, side, angle congruence. So sometimes highlighting helps, sometimes drawing helps. Apparently in this one I needed both of them in order to see my overlapping triangles. All right, so again we have some overlapping triangles, and again the fact that they overlap means that a bunch of triangles have formed. But I think sometimes when I look at what I have this angle and I have this angle. I have this tiny angle and this tiny angle, and then they share this side. So we're really talking about the whole big triangles that overlap. And again, I think it's easier if you redraw the triangles. I really do, and it kind of helps you see what's going on. So this was KLM. Excellent airline, by the way, but that's beside the point. And this one is KMN, not an airline at all. Okay, so we were given that L was congruent to N, and we were given that this little k right here was congruent to this little m right here. And then you can see, because on both of them I've got side KM, so that is my side that they share. So again, I have angle, angle, side going on. So triangle KLM is congruent to triangle MNK, and the reason for that is angle, angle, side congruence. So you can see that the overlapping side is super helpful, because otherwise I would have just had two angles and that wouldn't have been enough information to prove these two triangles congruent. All right, I want you guys to tell me what two triangles are congruent and why. So please do that. Hit pause now, come back and check your answer. All right, both of these triangles overlap at W. So angle W here is my overlapping piece that's going to allow me to say that they are congruent. So I've got these two triangles are congruent, and they are congruent by angle, angle, side. Okay, example 1 here is pretty easy, so I'm going to go ahead and I'm going to ask you about angle 1 in the notes, which two triangles are congruent and what the reason for that is in the notes check. Okay, let's talk about angle 2 here. So I'm given some information about some angles, and then I need to figure out which two triangles are congruent and why they're congruent. Okay, so this is another one where I've got multiple triangles going on. I've got this big triangle here and this big triangle here. They share this side, but that only gives me angle and side, so I can't use those two triangles. I've got these triangles right here, which I would have this angle right here, and that's really all I'll have of those. So those are no good. So it must be these triangles right here. So let me redraw that. So that is A, B, C. And then I have this one right here. Ooh, that's a bad triangle. That's a terrible triangle. BCD, even though it doesn't look like a triangle. And I've got this little angle C is congruent to this little angle B. The big angle B is congruent to the big angle C. And lastly, they both contain BC. So we have triangle ABC is congruent to triangle DCB. And the reason for that is angle, side, angle, congruence. All right, moving on to example 3 here. This one gets pretty complicated because all we have is parallel lines and then one congruency, but it would be difficult to see unless I redrew the triangles. So let's redraw these triangles. So I have one that looks like this, and that would be E, J, G. and then a second one that looks just like that, only this one is FKH. All right, so now I can go ahead and label this congruency that I've got. I've got EG is congruent to HF. And then remember we said whenever we're proving triangles congruent that parallel lines give us congruent angles. And in this case, these two parallel lines give me this angle right here and this angle right here. And those are corresponding angles, so they are congruent. And these two parallel lines give me this angle right here and this angle right here, because again, those are corresponding angles. So basically I have this angle is congruent to this angle and this angle is congruent to this angle. So now that we've redrawn our triangles, we can see that what we have going on here is angle, side, angle, congruence. And I'm getting bored writing congruency statements, so I'm going to skip it for this one. Okay, moving on to our next set of examples. These are a little complicated, they're a little confusing, but I have faith in you. So I am going to ask you for the reason why these triangles are congruent, and I'm going to ask you for that reason when you do the notes check. Likewise, on this next set of examples, I'm going to ask you for the reason why these guys are congruent in our notes check. So I want you to give it some thought. You might have to redraw it, whatever you need to do to figure out what triangles are congruent and why. Remember, we are talking overlapping triangles. So for example, in this here, obviously these two triangles are congruent by side, 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 but those are not overlapping. So I want to know which overlapping triangles are congruent. It's only two proofs and then we're done. So let's begin with our first proof. All right, we've got this pair of triangles here, and we are given that this little segment here, AX, is congruent to AY. And then we're given that these two segments are perpendicular and these two segments are perpendicular. And we need to prove that these two triangles are congruent. Okay, now triangle CXA is, let me see, this triangle right here. Okay, so that's that one. And then this triangle BYA is this triangle right here. So we need to say if we have enough information to directly go ahead and prove them congruent. And we have a side and we have an angle. So it would be super helpful if we could either have another side or another angle. And it looks like we're in luck because they both share angle A, which means that we do in fact have enough information to go ahead and prove them congruent right now. Okay, so all of this, I'm allowed to do this, you're not, goes right here in step one, and that would be my given. I'm feeling lazy, but you don't get to skip steps. Okay, and then two, we just said that angle A, and there's just one angle A, so we can go ahead and call it angle A. Angle A is congruent to itself, and that is my reflexive property of angle congruence. Okay, so now here's the deal. We've said that these two are perpendicular, which means that they form right angles. So I need to make some statements before I can go ahead and say that I've proven side, angle, side, because I've proven side and I've proven angle. I'm sorry, we're going angle, angle, side, or angle, side, angle, aren't we? But I don't yet have my other angles, so I need to get my other angles. Well, if CX is perpendicular to AB, that means that angle AXB is a right angle. And if BY is perpendicular to AC, that means that angle AYB is a right angle. So those two are right angles. And what would the reason for that be? If you said definition of perpendicular lines, then you are correct. My definition of perpendicular lines. All right, so I've said they're right angles, but I still haven't said they are congruent. So that's what I need to do next. I need to say that angle AXB is congruent to angle AYB. And that gets me my final angle that I needed. What is the reason for that? That is my right angles congruence postulate, also known as all right angles are congruent. I know that's hard for some of you because you think it's so obvious, but again, if you don't specifically make a statement that this angle is congruent to this angle, it doesn't count for your proof. All right, so now that we have proven angle and we've proven side and we've proven angle, we can go ahead and we can make our statement that triangle BYA is congruent to triangle CXA, and my reason for that is angle, side, angle, congruence. If you don't see that it's angle, side, angle, you can always go ahead and draw it. So that's my A, B, Y, and I have angle A. I have angle, I said this is Y, right? So I have angle Y, and then I have the side in between them. All right, so that's where I get my angle, side, angle from. Okay, moving on to our next proof. Okay, so I am given that FH is congruent to GE, which is a little hard to draw on my diagram, so maybe I'll just highlight it instead. So this guy, FH, is congruent to this guy, and then I'm given that this angle is congruent to this angle. And I need to prove these two triangles congruent, GEH and FHE. All right, so there's my problem right there. I need to prove that GEH, which is this triangle right here, my green one, is congruent to FHE, which is my yellow one. Now, they overlap this side right here, which is cool. However, and then these two sides were congruent. That only gives me two sides, and that's not enough information to prove those triangles congruent. Now, I do have, so again, I'm going to start switching colors here. Bear with me. I have this side and this angle, and then I have this side and this angle, and then they share this side. So I can prove that that triangle is congruent to this triangle, right? I do have enough information to do that. If I do that, the good news is it gives me this side right here and this side right here, which then, in addition to my two sides that I already had, give me three sides, and I can prove the triangle is congruent. So we're going to have to prove one set of triangles congruent in order to prove another set of triangles congruent. So let's do that now that we've got our strategy. So I'm going to take these guys, and they're going to go right here in number one, which is my givens. And then let's talk about our overlapping side, which is side FG. So side FG is congruent to side GF, and that would be, because these are overlapping triangles, my reflexive property. And these are segments, and they are congruent. So reflexive property of segment congruence. All right, so that I've got a side, an angle, and another side, which means that I can now say that those triangles are congruent. So I can say that triangle FGE is congruent to triangle GFH. And that would be due to the side, angle, side congruence postulate. Now, those are not the triangles they asked me to prove congruent, so I'm going to need to keep going. We said the whole reason why we want to do that is now we could start talking about their corresponding parts. And the part we really want to talk about is these two sides right here. So now I can say that FE is congruent to GH. And what's my reason for that? If you said CPCTC, give yourself a big pat on the back. All right, so now in this big triangle, we've got this side, but we didn't mention this side, so we need to go ahead and we need to talk about that side right there. So we need to say that EH is congruent to HE, and that again is my reflexive property. Okay, so now I have the first side, which I was given. I have the second side, which I got from CPCTC, and I have the third side, which I got from the reflexive property. So now I have enough sides to go ahead and say that triangle GEH is congruent to triangle FHE, and that is due to side, side, side congruence. Okay, this is called a double triangle proof. It's actually a little taste of what we are going to do in tomorrow's notes, but we went ahead and did it today just to kind of give you a advanced viewing of it. Okay, one of the things I do want to point out is you'll notice when I use the reflexive property, both times I reversed the order of the letters, so I didn't say FG was congruent to itself. That's because I knew in the triangles that I was going to say FGE is congruent to GFH. So the FG, FG, GF, GF. Same thing down here, EH, EH, HE, HE. Sometimes in the reflexive property, the segment stays the same, and other times it's reversed. It's still the reflexive property, and you just need to know, you need to think about what the final triangle is going to be to decide whether you keep it the same or you flip-flop the two endpoints. All right, this concludes the longest notes ever, notes 4.6. So please do the notes check, and if you have any questions, be sure to ask about them in class.